Sir, good afternoon.
Sir, good afternoon.
Sir, good afternoon. Sir, good afternoon.
Good afternoon. Sir, Anil Kapoor, sir, good afternoon. It's going live now.
Yes.
You can turn a little bit so that you can see others also. Hello. Amitabha Bhattacharyya, unmute. Hello. Can you hear us, sir?
Hello.
Hello, sir.
Yes. Am I audible?
Yes, sir. Can we start, sir?
Yeah.
Good afternoon and welcome back to all the participants. And today we have with us Sri Anil Kapoor, the Director HR, Director Power of the India's leading manufacturing organizations, the BHEL. He's a strategic thinker and co-creator. He's a leader for excellence with work experience from the shop floor to boardroom. He has done BE in electrical engineering from the University of Roorkee, presently is called IIT-Roorkee, in 1982, and 1 year diploma in SQC and WAR from the ISI Madras, and he had an intensive training in Germany in the machining of the components and manufacturing of 600 to 800 megawatt starter winding bars. His professional journey has been broadly seen 3 different segments. That means shop floor experience, HR related experience, and board level experience. Today, he is a dynamic board level executive having 4 decades of a deep and committed journey with India's largest engineering and manufacturing enterprise of its kind and the second largest employer in the Indian capital goods industry. He has experience of working on various assignments like strategy, visioning, execution of shop floor and corporate functionalities and interfacing with a variety of internal and external stakeholders like ministers, state governments, public and private international customers, and other employees and trade unions associations. He is a business leader with a strong technical and collaborative skills. Sir, we are very happy to invite you with a very busy schedule. You accepted our invitation for All India Manufacturing Design and Research Conference, one of the prestigious conference in India for manufacturing and design. And we are happy to have with you and share your expertise so that will be beneficial. All the young researchers, students, and others get the benefit and knowledge in the leadership, technical, and managerial skills. Thank you very much, sir. And
ठीक है. Good afternoon. Thank you very much, Doctor, for introducing me so nicely, so beautifully.
Yes, sir.
It is indeed a pleasure to be with the students of your IIT, and I hope I'll be sharing the information that will give them some insight into what this Navratna company does in the progress of the country. So I'll start with a brief introduction of the company, and then I shall slowly tell what kind of innovation structure we have and what we are doing in diversification. Because diversification is the need of the hour today. Shall we begin? शुरू से पहली स्लाइड से स्लाइड नंबर BHEL is one of the largest engineering and manufacturing enterprise of its kind in India, and we are there since 1964. So, as a matter of fact, when we are talking about Make in India today, but we, as a matter of fact, started this process more than 50 years back in 1964. We have been catering to business in power, industry, and infrastructure sector. We have more than 190 gigawatt power generating capacity that is stored. In India also, more than half of the electricity generated in the country comes from sets installed by BHEL. We have got 16 manufacturing units spread all across the country, 8 service centers providing services to different units, different power plants. And we at one time normally work at more than 150 locations. BHL is second largest employer in India in capital goods industry. We have been paying dividend for 4 decades. Last 2 years we could not do because of certain constraints. And we have till now contributed more than 20,000 crores to the exchequer in the last 5 years. Next, please. This is our global footprint. We are providing services in more than 80 countries. Next. And this is how we are present in India all across through, as I said, through our offices, through our manufacturing units, service centers. Next. Here you see installed capacity. Our installed capacity is 53% of the total Indian power sector, but generation is 56%. So if we go percentage-wise, we are generating more than what is being generated by others. So this chart shows that. And this is how we are placed in the core sectors of our economy. Power sector, we are doing thermal, gas, hydro, nuclear, emission control equipments, captive power plants, transmission systems we are doing, and we are present in renewable sector also. And in industry, we are doing oil and gas industry, transportation, railways, we are there. Defense, we have been serving for almost 30 years through our ship-mounted guns. E-mobility, we are there. And water business also, we are doing a lot of work. So now I would like to share some information about what we are doing. As I said, R&D and innovation have always been critical drivers for BHEL, and that reflects completely in our journey over the decades that we must have seen. BHEL is one of the highest spender on R&D and innovation. It's filled with consistent expenditure of over 2.5% of our turnover in the last many years. As a result, BHEL's products have always been in line with the latest technologies and consistently displayed high reliability, efficiency, and cost competitiveness. BHEL has always has a well-established R&D infrastructure across the company. We have got corporate R&D division at Hyderabad, which is the pivotal center for all research activities. It is supported by advanced facilities and highly qualified and experienced manpower. Company's R&D infrastructure also includes in-house R&D centers at more than 12 manufacturing units, 14 centers of excellence with state-of-the-art facilities, 5 specialized research institutes, and a well-established network of industry academia collaboration that we can have with many IITs and other institutes. BHEL has always believed in achieving technological excellence through a judicious mix of in-house development coupled with collaboration with technology leaders, global OEMs, as well as academia. BHEL has successfully worked with global majors like GE, Siemens, MHI, among others. Recent times, we have witnessed a rapid change in the technological landscape, which has had a far-reaching impact on existing business, as well as thrown up many new unaddressed opportunities. Company's innovation ecosystem also has revamped in line with renewed focus on introducing new products and services as per market requirement in the shorter term, as well as working in emerging and futuristic areas that I'll come later. Company's focus areas include clean coal technologies that we must have seen there is a lot of emphasis on this, decarbonization efforts, renewable railway transportation, defense and aerospace, industry 4.0, battery storage systems, among others. Development of ambitious future technologies like hydrogen, battery energy storage, additive manufacturing is also being focused upon to ensure countries' technology leadership in technologies of tomorrow. Some of the latest development in upcoming and futurist areas I would like to elaborate. In power sector, being a leader in the Indian power sector and taking cognizance of the ensuing and much needed energy transition, BHEL is focused on developing green technologies in the power sector, including clean coal, conversion technologies, pollution control equipments, high efficiency, low emission technologies, advanced nuclear technologies, among others. Introduction of supercritical technology has been one of the most important development in Indian power sector since the 500 megawatt sets were introduced by BHEL in the country. BHEL has maintained the leadership in the development of supercritical technology in India. In a major leap, India has embarked upon the development of an advanced ultra supercritical technology, that is AUSC. Only a very few countries in the world are currently working on this technology, and India could be among the first in the world to demonstrate the technology and deploy it commercially. BHEL is at the forefront of this technological revolution and is developing the AUSC technology in collaboration with NTPC and IGCAR to reduce carbon emissions and achieve higher efficiency of 46%. R&D phase of technology development has been completed. BHEL is now geared up to set up 800 megawatt technology demonstration plant at NTPC CPET site in the next phase. This development will be a major step forwards towards cleaner utilization of coal and will pave the way for thermal sector in the near future. So efficiency will go up, carbon emissions will come down. BHEL is already offering solutions required to meet the stipulated emission norms in force for generation utilities. The company is executing boiler design modifications, installing FGD systems for reduction of SOx emissions and improvement in particulate collection efficiency of ESPs. BHEL has indigenously developed SCR technology exclusively for high ash coal fired Indian thermal power plants through its dedicated R&D efforts. BHEL is working on development of technology for conversion of high ash Indian coal to methanol that you must have seen in news also. Successful implementation of this technology will help generating methanol for industrial scale for its use in blending with petrol, which can significantly curb the rising crude oil import bill of the country and improve the energy security of India. This can also be blended with the coal in the power sector. 0.25 TBD methanol generation pilot facility is under execution at corporate R&D. BHEL has been leading from the front for over 4 decades in the development of country's nuclear power segment, with it being the only Indian company to be associated with all the 3 stages of nuclear power program. BHEL is the only company in the country having design and engineering capabilities in TG sets for nuclear applications, and the result is that 12 pressurized heavy water reactors out of the total 18 operating in the nation, accounting for 75% of the nuclear power capacity, are equipped with BHEL supplied steam turbine generator sets, and rest are imported ones. So nobody else does it in India. 10 units of 220 megawatt each and 2 units of 540 megawatt. This showcases the contribution in helping attain maturity of the first stage of indigenous nuclear power program of the country. You must have heard that one of our sets, Kaiga, provided the longest service record. It worked for more than 500 days. BHEL has reaffirmed its leadership in engineering and manufacturing of nuclear steam turbines and is fully geared up to address the 7 megawatt TG Island business on EPC basis for upcoming PHWRs, which are being procured by NPCIL under fleet mode. That was in power sector. Now in industry sector, BHEL already offers a broad range of industrial systems and products for the major sectors of the Indian economy. Focus today is on developing and offering comprehensive solutions for transportation, transmission, renewables, defense and aerospace, energy storage and other similar applications. BHEL has been a long-standing and reliable partner for Indian Railways, offering a wide range of products and propulsion systems for all type of rolling stock. In the recent years, many new developments have been made and introduced on commercial scale in line with Indian Railways technological advancement. Indian Railways first 900 HP freight locomotive equipped with propulsion system indigenously developed and supplied by BHEL has been developed, supplied and commissioned in this year. This loco will be used in western and eastern dedicated freight corridors, substantially improving the efficiency of Indian Railways freight operations. Adding to the many firsts among its offerings to the Indian Railways, in the recent years, the first air-conditioned local train of Central Railway manufactured by BHEL and ICF was put in passenger service from Thane to Panvel, Mumbai in January 2020. BHEL has so far successfully commissioned 9 air-conditioned ACMUs, local trains for Western Railways and Central Railway to provide metro-like comfort for local commuters of Mumbai. BHEL has also developed a regenerative braking system, which has been retrofitted in 5,000 HP WAG 7 electric locomotives of the Indian Railways for the first time. The system will lead to a recovery of approximately 15% of energy consumed during motoring, which was otherwise going waste. BHEL has indigenously developed passive emitter rear cell PERC technology for higher efficiency of solar cells. As a part of indigenization of imported equipment in strategic applications under Make in India, BHEL has developed a 750 kilowatt, 104 hertz, 520 RPM reversible permanent magnet synchronization reserve propulsion machine. The machine has successfully completed endurance testing of 2,500 hours of continuous operation. BHEL continues to be a reliable supplier of strategic equipment and services to the defense and aerospace for over 3 decades. That very few people know. We are mainly known as a supplier of power equipment, but this is also a fact that we have been working with ISRO for more than 3 decades. BHEL takes immense pride in its association with all space programs of ISRO. Missions of national importance, including the INSAT, GSAT, IRNSS series, and RESET series, have been powered by BHEL manufactured space-grade solar panels and lithium-ion batteries. BHEL has also been supplying titanium alloy-based spacecraft propellant tank components to ISRO. BHEL has also reached the unique distinction of supplying the 100th space-grade battery to ISRO for Chandrayaan mission. BHEL is developing products and systems for digital substations and advanced power transmission like 800 kV HVDC, 765 kV, 1200 kV transmission systems. Development of system solutions for e-mobility ecosystem, including e-bus, powertrain, charging stations, energy storage systems are other fields where we are working and trying to help the industry in that area. I have told the main activities being done in R&D and diversification. Now I'll take this presentation forward so that we can show you some of the slides to give you a picture of what is really happening. So these are the major offerings. As I said, power sector, we are in thermal, hydro, gas-based and nuclear. And thermal, we are doing emission control, which is need of the hour. Next, please. Renewable, we are there, and we have done even floating solar panels we have installed. They are we have done for NTPC in Simadri, then we are doing for Telangana also. So this is a very difficult thing to do, but we have mastered it. In a few days from now, maybe within a month, we'll be having few more sets of floating solar commissioned by BHEL. Next. This is, as I said, low transportation system. We are there. The local EMUs, urban trains. We are present everywhere, and we are trying to give railways the latest technology available. Next. This is, as I said, in transmission business, we are working on high voltage levels, HVDC and 750, 765 kV and 1200 kV levels. Next. We are doing a lot of work in defense and aerospace. As I said, we are doing even for Tejas also, we are giving condenser. And we have been giving this ship-mounted guns for more than 30 years, I would say. And, more than 40 guns are already installed on the ships. And now, latest version also we have got some orders, and we will be updating in these guns and giving them new technology guns for mounting on the ships. This is regarding our presence in industry sector. It's a large number of AC machines we have done, compressors, oil rigs, and I'm very happy to share that our oil rigs are supposed to be giving the best performance in the market. There's a different type of valves we do. Even under Make in India, we are developing a few valves for ONGC, and that will also add to our portfolio. Next. As I said, BHL has always been working for new products and new technologies, and our efforts have been appreciated at different levels. As you can see, we were winner of the following awards that are displayed for your information. This is, as I said, this is the structure that we have. We have got our corporate R&D, and as I said, that 2.5% of our turnover we spend on R&D efforts. 14 centers of excellence we have for bringing new technology to India. We have got 12 active technological collaborations, and I would like to share here, we even in these collaborations, we try to make the things suitable for our own Indian conditions, because every time whatever technology we bring, it may not be exactly suited to our kind of environment, or in say thermal, maybe our kind of coal that we have. So we not just copy the technology of others, we make it suitable to our own Indian conditions. Next, please. This is, you must have heard, advanced ultra supercritical technology. This we have developed the design, and when we go for these sets, efficiency will go up by 5%, and when efficiency goes up by 5%, coal consumption will come down by 11%. So we are ready with the design, and now in this, because this project was funded off by our ministry and Department of Heavy Industry. And now for second phase, that is for bringing this as a project. For that, we will be working in the second phase for bringing one set in live. This is, as I said, we are working on coal to methanol, not only for blending in petroleum, but it is being planned for use with pulverized coal also in the power stations. So that will work on. At the same time, I would like to share that we hear a lot about this paddy being burnt. So that project also we are working on with some power stations. At national level, there is already one mission which is working on this, and we are also associated with that. And in two of the power projects in Punjab, we are closely collaborating for burning those capsules, pellets they make of this paddy, and then it is burnt with the coal. So that study will be associated with, and hope this problem of pollution will get addressed. To address the problem of air pollution, we are developing one product, air pollution control tower. So one tower we have already installed in Noida for demonstration, just to making study that how it works and what needs to be done to make sure that we are able to address the problem of pollution in bigger cities. So this has been installed recently, and it was inaugurated by our Minister of Heavy Industries. We all know that during the second phase of Corona, there were a lot of problem because of non-availability of oxygen. So, in collaboration with CSIR, we worked on these liquid oxygen plants, and in a very short time, we were able to develop and install these oxygen plants. This effort has also been very well appreciated by all the customers who placed faith in our ability. Next. As I informed you earlier also that we have been working for ISRO for lithium-ion cells and PV modules. We are developing on PERC cells for solar system, for solar panels for higher efficiency. The WAG 7, this 9000 HP WAG 9 we have developed for railways. These are all new developments. We have got this platform for innovation through collaboration, in which we are collaborating with the academia and industry. There are a large number of people who have registered on this, and we continuously work on the problems given, and we try to work on solutions with the help of experts who are also registered on this platform. So that is one system we follow for looking for identifying problems and providing solutions. Now, because power sector, we have already seen that thermal, we have got issues because of pollution issues. So we are exploring more and more in the industry sector, and for that certain diversification initiatives we have taken, and we sat with the experts. Then we had a study done through different forums, and we were able to zero down on some of the products where we have got synergy in with our existing facilities, with the technology that we have. So we are getting into railways, downstream oil and gas, defense and aerospace in a big way in diversification. So these are the new products that we have developed or we will be developing under collaboration for diversification. Downstream oil and gas also, we have got to this field, and we have got some orders also. And with our existing facilities, we hope slowly we'll be able to make mark in this area. Today also I'm having a review in Haridwar, and there also we are developing some new products in oil and gas sector. Even for ONGC under Make in India, we have got some orders, and we are getting the items developed in through our R&D, and we are manufacturing certain items in our facilities at Hyderabad and Trichy. Next. Then spare and services is one more area where we are going to come in a big way. First, because of solar, there is a lot of emphasis on flexibilization.
Hello.
Because, yes.
Sir, sorry to interrupt. Have a next speaker is online, sir.
Okay.
Can we take it some couple of questions?
Okay. Yes, please.
Participants, if you have any questions, you can please ask.
Sir, I think there's no questions from the participants. I request you give some advice to our young researchers and students how they can choose their career, because there are so many opportunities are available as per your speech, defense sector and aerospace and everywhere that you're talking about. But I think now the students or youngsters are a little bit confused. Can you please give a piece of advice for them?
See, field that you choose, one that you should have competence in that field, because presently there are, even say thermal sector, if we say, it may be we can say that orders are coming less and less, but still there is lot of work to be done in this area also. Like for these SOx, NOx, there are issues, and technology is coming, but there is too much dependence on Chinese products. So if people can work in that area, that will be a good thing. And renewables, solar, like we are working on this improving efficiency. Because if we want to really contribute, we have to go for a field where already China is there, but we can beat China by improving on technology. So I would suggest that they go for a product, go for a technology which can give India a technological edge. Because only technology can lead to success, and I would say profits in the longer run. Capacity wise, we cannot beat Chinese as of now. It is only technology. If we develop higher level technologies, then only we can say contribute in the growth of the country. So this is what I feel.
Sir, thank you very much, sir. for your advice and a lot of information from BHL. With your
So the pleasure.
permission, can we wind up the session, sir?
Okay, thank you.
Thank you very much, sir. Thank you for your advice and a lot of information. And on behalf of Aimtdr conference, once again, we'll thank you and your time for spending your valuable time with us in spite of your busy schedules. I understand that you are very busy and a lot of travel, but thank you very much. And we had little time for you also, that we are sorry for that. And thank you very much, sir. Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Good evening, one and all present here. It gives me immense pleasure to extend a warm welcome to all of you for the session on industry, academic and interaction case study. Now I request Dr. P.R. Taylor, Professor and Head, Department of Mechanical Engineering, PSG College of Technology, and Principal Investigator of DRDB project to brief about the session. Ma'am, you can take over, ma'am.
Thank you. Thank you.
Thank you, ma'am.
Good evening to one and all who are present with us today. I welcome all of you to this session on industry academia interaction, a case study. For any field to grow on a sustainable and continual basis, the development and implementation of new innovative technologies is essential. Industry academia collaboration will enable the fusion of the core competence of both of them, and it is a key catalyst that will promote innovation and growth in technology. A slide on industry academia collaboration was also highlighted by the previous speaker, Dr. Anil Kumar. We at PSG College of Technology carried out a prestigious project under the aegis of the Office of Principal Scientific Advisor to the Government of India, which pertain to machine tools. In case of machine tools, vital requirements like increased accuracy and productivity at reduced cost demands high cutting velocity, high spindle speeds, and high feed rates for the machine tool to be operated at. One of the best methodologies to realize this is to build machine tool structures with materials that have enhanced stiffness and damping properties. Recognizing the need for the development of an alternate material as a substitute for the conventional materials used to build machine tool structures, the Department of Mechanical Engineering of PSG College of Technology joined hands with Bharat Fritz Warner Limited, Bangalore, and Galaxy Machinery Private Limited, Belgaum, who are leading manufacturers of high-precision CNC machine tools in India. And we submitted a research proposal to the Office of the Principal Scientific Advisor to the Government of India, and the project got sanctioned. The objective was to develop a polymer concrete material with enhanced damping properties to build machine tool structures, with the foresight that the outcome of the proposal would help the Indian machine tool industry to compete with global machine tool manufacturers and augment the nation's economy. Through this project, an excellent model for industry academia collaboration was established, and it was highlighted in yesterday's inaugural function also. And at this juncture, we wish to share our experiences through a short video. Thank you. Thank you very much.
Madam, over.
Apart from providing extraordinary education and fostering research and development, PSG College of Technology continues to be the home to thousands of students, research scholars, and professors, and many others every year. It is situated in Coimbatore, the Manchester of South India, which is known for its rich black soil and its pleasant climate all the year round. It is the reason for its successful growth of cotton, giving it its status as a hub for textile industries. There are more than 25,000 small, medium, large-scale industries and textile mills in Coimbatore. For its foundry, manufacturing of textile industrial equipment, water comes in, and this is where PSG Foundry Division comes in, providing reliable and competitive casting to its customers. To the mission shop, a PSG Industrial Institute, even the students of PSG get to be a part of the industrial process of manufacturing. With close-knit interaction with industry, the Department of Mechanical Engineering was awarded as the Best Industry-led College with the AICTE-CII Award. The core test laboratory, Industry 4.0 laboratory with advanced facilities such as 3D printing are some of the advanced laboratories established by the Department of Mechanical Engineering. The main requirements expected of modern machine tools are productivity, precision, reliability, and the capacity to machine new materials. High accuracy machines using epoxy granite structural material are available abroad. In an attempt to have such technologies in India, the Indian government has set up the Make in India initiative to bridge the technological gaps here by encouraging industrial academia collaborative projects. PSG is contributing immensely by working on the dynamic response and damping properties by involving alternate materials to improve machine tool structures. With the support of the Office of Principal Scientific Advisor, PSG College of Technology, being the academic partner, is working with industry partners Bar and Fritz Werner, Galaxy Machinery Private Limited, and the testing partner Aimtdr in developing this material. PSG has established the Machine Tool Research Center with all kinds of facility for the successful development of these materials, thus taking the focus of manufacturing research from the macro scale to the micro and nano scales. The objective of this project is to design and develop machine tool structures by using novel polymer concrete materials, which will enable the operation of machine tools at high speed and feed rates with better static and dynamic responses. Now, we will look at how polymer concrete is developed and tested. This is the characterization piece. These are the materials developed. These are some of the equipments used to manufacture and test the polymer concrete. Prototypes have been designed and developed with structures made of the polymer material. Both the Galaxy Lake and the BMW BMC shown have structures that have been developed using the polymer concrete. The process of making the polymer concrete comprises of the following stages. Granite aggregate is prepared from the raw materials by crushing and sieving. Epoxy and the hardener are mixed together. The aggregate is mixed with the epoxy mix. is built. And finally, compacting and curing is done. As the machine tool structures are made, and radiography test of the polymer casting is done. The developed structures are near net shape and hence require minimum machining. The structures are assembled as you can see from the lathe bed assembly. These structures have excellent dynamic response, apart from many other benefits such as stress-free castings, corrosion-free structures, 5 to 8 times improvement in damping capacity, and improved natural frequencies due to high stiffness to mass ratio. High hardness materials and high precision aluminum components can also be machined. There is a 25% improvement in surface finish when compared to lathes and VMCs using cast iron structures. As a result of our efforts, this project will bring monumental transformational changes in new machine tools, enabling them to work at higher speeds and feed rates. We would like to thank the expert committees for providing us with the support we needed. We also extend our gratitude to the research team for mentoring and guiding us. Dr. Harshit Soname from our industry partner, Bharat Fritz Werner, shares the BHW's experience in this project.
Hello, and warm greetings to all the participants of Aimtdr. I am Dr. Harshit Soname. I am heading research and development activities at Dr. Kalam Center for Innovation, Bharat Fritz Werner, BFW. So today I am here to talk about industry, academia, and collaborative project. So this kind of project usually has 3 major entities. So first one will be the proposer. So Department of Mechanical Engineering, PSG College of Technology was a proposer for this project. BFW and the Galaxy Machinery were the industry partners. And it was funded by Government of India, especially the Office of Principal Scientific Advisor to the Government of India. So the major objective of this project was to find and to develop the alternate material for machine tool structures. So usually if we observe, most of the machine tool structures are made out of cast iron. So the objective defined for this project was to replace cast iron with the polymer concrete. So the machine defined by BFW was a vertical machining center, BMV 45 plus, where the base and the column was supposed to get replaced by a polymer concrete structure. So this project, basically this product development has involved 9 major steps. So first step was to benchmark. So a lot of tests have been carried out in cast iron machine, where the mechanical properties have been noted down as a benchmark for the upcoming epoxy granite. or the polymer concrete machine tool structure. Second step was to develop the material. So epoxy granite basically involves ingredients as of mineral particles, different sizes of mineral particles, epoxy resin, as well as hardener. So the effort of the committee was to locate or to find out the local source of these constituents. So we have successfully located the local industries for epoxy resin and the hardener. So the blocks, different sizes of blocks have been manufactured by PSG team, and it has gone under different testing set of testings where properties have been decided, and we have boiled down to the combination of the polymer concrete. Next step, major step, I would say, was to design finite element analysis components, 3D components for base as well as columns. Team PSG as well as designers from BFW, they have worked significantly to come up with a completely new design for structures. So then the major thing was to pour this material, polymer concrete material. So molds also we have defined and designed ourselves by our designers. So once we pour this material into the mold boxes, the final shape of the column as well as base for this VMC have come out, and these structures have been sent to BFW for assembly. So for assembly people also, it was a completely new work, but they appreciate their efforts that they have considered this as a challenge, and they have converted these individual machine tool components into a complete machine. And the final step was to analyze the performance of the epoxy granite machine tool, a complete VMC machine. So a lot of tests have been carried out to define the static as well as dynamic stiffnesses of this machine, as well as damping characteristics for this machine, and all the properties and performance characteristics were compared with the cast iron machine. So to summarize the highlights of this project, I would say that three major highlights. So first one was more than 10 patents have come out as a result of the research conducted throughout this collaborative project. Second one was a state-of-the-art facility has been developed at PSG College of Technology, where the raw materials such as particles and resins can completely get converted into the machine tool structures. So I would like to appreciate the efforts of the PSG team to come up with this facility. And third thing, as a product, I would say that the world-class product as a epoxy granite VMC machine is a result of everybody's effort from this project. So I would like to thank the academia, the industry partners, my management, and the review committee, the government of India for taking this project. And I would say that this project has come out as a great success in all the dimensions. So with this short video interaction, I would like to wish the participants of the Aimtdr and the organizing committee a great success. Thank you.
Yes, Ilango, the Managing Director of Galaxy Machinery Private Limited, who is our industry partner in the dynamic response and damping properties of machine tool structure, the DRDP project conveyed a message. Please accept my heartfelt congratulations for achieving this far in this project and it was a thorough professional approach from PSG Tech, for which it is known for. Entire team of this project, under the leadership of Dr. Professor Taila, has put in such a great effort to this research project. Please keep it up, and I request PSG Tech to undertake more such projects to resolve the technical challenges picked up from industries and continue to be the leading light to guide the industry. Quoted S. Ilango, the Managing Director, Galaxy Machinery Private Limited, Belgaum.
Ma'am. Ma'am, shall we hand over the session to the keynote speakers now?
Definitely, definitely. It's
Thank you.
already time.
Yes, ma'am. Thank you, ma'am.
Thank you.
I hope you can hear me.
Yes, sir, we are able to.
I hope you can see me also.
Good morning, sir. Good morning.
Good morning. So I'm ready whenever you are, and I will then start sharing my slides.
Yes, sir. Just 2 minutes, sir.
We're all ready, sir.
No problem.
Good morning, sir. Good morning.
Good morning.
Sir, Professor Bhattacharya, sir. Unmute him.
Hello.
Hello.
Sir, can you hear us? Can you? Yeah, okay.
Yeah,
Sir.
yeah.
Okay, sir.
Oh,
Can we start the session, sir?
yes, certainly.
Good evening to all the participants in India, and very good morning to Dr. Vijay Srinivasan. We'll be having the next keynote session, the keynote session 4, which will be delivered by Dr. Vijay Srinivasan, the Division's Chief Systems Integration Division, National Institute of Standards and Technology, USA. She'll be talking on emergence of the biotechnology platforms during the COVID-19, a lesson in product development and manufacturing. Sir, we, on behalf of Aimtdr, we welcome you, sir, for this keynote session. And we request Professor Vijay Bhattacharya, Professor, Department of Production Engineering, Jadavpur University, to chair the session.
Thank you.
Thank you, sir.
Dr. Tal. First of all, I want to thanks the organizing committee of 8th International and 29th All India Manufacturing Technology Design and Research Conference, Aimtdr 2021. I thank you for giving me the opportunity to chair the session. So as already Dr. Tal described about our learned keynote speaker, about Dr. Vijay Srinivasan. About his detail, he is going to deliver the keynote lecture on the topic of emergency of biotechnology platform during COVID-19, a lesson in product development and manufacturing. So I request Dr. Vijay Srinivasan to start his keynote lecture.
Thank you very much, Professor Bhattacharya, for the kind words. And I will start my lecture by sharing my slides. So I am doing that. And I hope that you can see my slides.
Yes, sir.
Okay, very good. Now that you can see my slides, I will start by making some very brief comments. It's my pleasure actually to be with you remotely this time. I remember about 10 years ago in the year 2011, I was at PSG Tech in person. At that time, they were celebrating the 60th anniversary of the establishment of the PSG Tech. And it was my great pleasure to meet with many of you and also give a talk at that time. Now, 10 years later, this is the year we are celebrating the 70th anniversary of the founding of PSG. And at the same time, we have this Aimtdr conference, a very prestigious conference in this series. I wish that I could be with you, but for obvious reasons, we are all meeting remotely. In fact, it turns out that that's one of the reasons why I chose this particular topic to talk to you. Because for the last nearly 2 years, this pandemic has been with us. The COVID-19 pandemic has been with us. And this has been a very tragic time for many people around the world, because many people in the world have lost their lives, including people in the United States and in India. And it is still affecting a lot of our lives and our livelihoods. But in spite of all these problems, there is a small silver lining in this otherwise dark cloud. So what I would like to do is to use this opportunity to learn some lessons. So these are the lessons that we have learned over the last 2 years, because the COVID-19 has taught us the power of the so-called technology platforms, particularly the biotechnology platforms. So the biotechnology platforms that I will talk about today were used or are even being used for the development and deployment of vaccines. As you know, vaccines are the most effective way for us to get out of this pandemic. And in the process of describing the biotechnology platforms that has been helping us to develop the vaccines at an unprecedented rapid rate, this is also teaching us about product development and manufacturing in general. So I will speak a little bit about how product development and manufacturing have been going on for quite a while, but we are learning some new lessons because of the biotechnology platforms. And I will also mention, moving beyond the vaccines, how these types of platforms, particularly the biotechnology platforms, will be very useful for us moving ahead in this particular century. So this is the theme of the keynote. That is, the COVID-19 has taught us the power of platforms, and the outline that I just spoke to you about. I must also mention that this COVID has also taught us a lot of biology. And as an example, in this slide, I show you the major culprit that we are facing. So the virus that we are facing is called SARS-CoV-2, as you see up here, over here. Now, the SARS-CoV-2 is the virus, and the disease that it causes is the COVID and COVID-19. The virus itself is extremely small. So if you look at the picture of this particular virus that I show on the left-hand side, it's about 100 micrometer in diameter, 100 nanometer in diameter, as you see over here. So 100 nanometers is extremely small. It's about 1/100th of the width of a human hair, roughly. So it's an extremely tiny organism. More importantly, the culprit within that organism is the so-called spike protein that you see over here. The spike protein is only about 10 nanometer in its length. So it's even much smaller than the overall virus. It is the spike protein that had been identified as the antigen in the virus, which is called the main culprit here. Now, the antigen that we worry about in this particular case, the spike protein, is the one against which we are developing lots of vaccines to create the antibodies that will neutralize this particular spike proteins. In fact, many of the genetics-based vaccines that I will talk about actually target this particular spike protein. So this is the antigen in the bigger virus that we have to worry about. Okay, now the inside of this particular virus, we see the messenger RNA. So this is the genetic code that the pathogen, the virus, carries with it. And the genetic code is the key for the virus to get into our cells, hijacking our machinery, the machinery of our living cells to reproduce itself. The virus cannot reproduce by itself, so it needs our cells to get into our cells and reproduce itself. Okay, now there are some more details on the right-hand side that you see here that talk about how the virus itself has been sequenced, or the genetic code in the virus has been sequenced. It's about 30 kilobyte long, kilobases long, and so on. But the more importantly, let's look into what this particular virus is causing the problem for us. Now, to combat the virus and the disease that it causes, as I mentioned, the vaccines have proved to be the most effective way to combat this particular pandemic. Now, the WHO organization, this is the World Health Organization, it has been publishing a landscape to track the development of vaccines for this particular virus for nearly 2 years now. So this is a very extensive tracking and communication. They update the particular website that I show you at the top of this particular slide twice a week, Tuesdays and Fridays. So when I looked up at the database, sometime middle of last month, that on November 15th, you will see that there are 132 candidate vaccines that are under clinical phase. So these are not just under development, they are being tested on real human beings. So there were about 132 vaccines all around the world that are being tested on human beings. Out of these 132 vaccines, a few of them have been already approved for use at either emergency use authorization or a full authorization for people to be injected with these vaccines. Now, interestingly, these hundreds of such vaccines have been classified under the 11 platforms that I show you on the left-hand side. So if you see the starting with the PS, the protein subunit at the top, going all the way to BACAG-SPV at the bottom. So there are about 11 platforms under which these vaccines have been classified. So this was the story in the middle of last month. If I look at the most recent statistics, that is as of the Tuesday, most recent Tuesday, December 7th, the number has jumped to 136 vaccines products that are being tested, going through the clinical phase in various parts of the world. Again, these are classified under the 11 categories of platforms. So the question naturally arises as to what WHO means by platforms. Particularly, what do they mean by the vaccine platforms? And I will spend bulk of my talk describing to you what the WHO means by platforms, because when you have hundreds of products, it makes sense to classify them, to group them so that we can compare and contrast the various vaccine products. That's one of the main reasons why people do the classification. And the classifications are also extremely helpful in us understanding what's going on and making future progress in this particular area. So among the 11 platforms that are indicated here, and as explained by the WHO organization, what I will do is that I will pick a few of the platforms and try to describe to you what they actually do. that is the vaccine products that are coming out of these platforms. What do they actually do? For this, I need to tell you a little bit about the human immunology. So most of the human beings have built-in immunity systems to fight the invaders like the viruses. Now, what I mean by most humans is that there are a few of us are immunocompromised. So a few of us don't have this ability, but most of the human beings have built-in immune systems. And the vaccines that I'm talking about depend upon the human's innate ability to fight the invaders. So what most of the vaccines try to do is that they mount a fake attack to fool our body into thinking that a real attack by the virus has taken place. Then what happens is that our body then mounts a counterattack in the form of B cells and T cells. And in particular, the B cells will secrete antibodies. So these antibodies and the killer T cells will be stimulated in our body to counter this fake attack. But the point is that once the body is primed with that, the body will be well prepared if and when the real attack occurs. So there are traditional vaccine platforms. In fact, we have been using vaccines for over 200 years in various forms. And the traditional vaccine platforms include the inactivated virus and live attenuated virus. These are two of the 11 platforms that I showed in the previous slide. And what we do here is we essentially take the virus, we pretty much kill it, we make it inactive, and then we inject the carcass or the body of the virus, which is pretty harmless. And we inject the body of the carcass of the virus into our bloodstream, into our body. Then what happens is that the body thinks that these are real live viruses, and then it reacts to it by generating the antibodies and T cells and so on. That's how we build the immunity to the virus when it actually attacks us. The actual active virus attacks us. But what we have done in the last 2 years is novel. We have also created novel vaccine platforms. These are the so-called mRNA and viral vector non-replicating. Also there is replicating, but in this particular case, I have chosen the viral vector non-replicating platforms. So these are the platforms that are also used very successfully actually. So in this case, we inject only the genetic code. So in the picture of the pathogen that I showed in the last slide, where the RNA contained within the virus, so we read the genetic code. We can do that because the biotechnology has advanced to a stage where we can actually read the genetic code of the viruses. And we then create a genetic code that corresponds to the particular part of the virus, namely the spike protein that I showed you. And then we inject only the genetic code corresponding to the spike protein. Then the human body will look at the spike proteins that are generated in our body, and I will tell you a little more about that soon. And then it can generate a immune response to that, very similar to what the traditional vaccine platforms had done. So the big difference these days in the last couple of years during the pandemic, what we have done is we have introduced the novel vaccine platforms, in particular the mRNA, messenger RNA, and viral vector platforms, and they have been spectacularly successful. So, for example, I have received vaccines that are generated by the novel vaccine platforms, both my regular vaccines as well as my booster vaccine recently. They all are based on the novel vaccine platforms. Now, if I look around the world, nearly half the vaccines are still manufactured using the traditional vaccine platforms, the inactivated virus and live attenuated virus and so on. But the novel vaccine platforms constitute roughly the remaining half of it. So you may have heard of the AstraZeneca Oxford vaccine, the Sputnik V vaccine, and Johnson & Johnson vaccine. So these are all viral vector vaccines. And you may have also heard of the Moderna vaccine and the Pfizer vaccine. And the Moderna vaccine and the Pfizer BioNTech vaccine, they are all based on the mRNA platform. So we have several platform technologies that are now in the use, and these platforms have corresponding products, the vaccines, with the varying degrees of effectiveness. And we are learning a lot coming from the real world data on how effective and safe these vaccines are. So what is the mRNA platform? I'll explain that to you very briefly using the cartoon picture that you see on the left-hand side. So what we do in the mRNA platform is that we have the so-called lipid nanoparticles. So these are very simple, long molecules that self-assemble. And we have the RNA, the messenger RNA, and we encode the messenger RNA into the lipid nanoparticle. So you see the RNA1 is one particular RNA that corresponds to one particular virus. So if we include the messenger RNA and insert it into the the messenger RNA is inserted in an envelope of this lipid nanoparticles, and then we inject it into the patient. Then it gets into the cytoplasm of the cell, and there is ribosome, which is an enzyme within the cytoplasm, and it translates the message, the mRNA, and produces the spike protein. And the spike protein then gets out of our cell, and the body recognizes that, and the immune system of our body responds to the fake attack mounted by the spike protein. The interesting observation is that the ribosome that I mentioned, which is the one that is used to translate the mRNA into the protein, is an amazing machine to make proteins. In fact, the more I look at it, the more I am amazed by how smart and clever these machine tools are. Very similar to the very sophisticated machine tools that we have in our factories. But these are a million times smaller and much, much more efficient and smart than what we ever have made as machine tools in our factories. The mRNA also is informational. That is, it can be tweaked to produce any protein that we want. So that's one of the major benefits of using this novel vaccine platforms, because the informational aspect of it is very much like software. We will be able to, or we are able to, tweak the mRNA by just changing the software associated with the genetic code, which can be done very quickly. And then we can use the rest of the processes as they were before to make the new product. So I will I'll come back to this and refer to this often, because this is very important. The way in which modern biotechnology has transformed the various platforms, and the technologies that are available to us can actually help us to produce the vaccines very quickly, and we can also customize these vaccines to specific diseases. Now, the next platform that I want to talk about is the viral vector platform. So in the viral vector platform, the situation is somewhat similar, except that the package or the medium through which we communicate the genetic code, this is the DNA here, the medium through which we communicate the genetic code is a viral vector. It's a relatively harmless flu vaccine. So a message in the form of a DNA, not the RNA. The DNA is inserted into the envelope and it is sent to the body. It is injected into our body and it enters the cell nucleus. Once it enters the cell nucleus, then there is an enzyme called the RNA polymerase. Then that actually transcribes or makes copies of the DNA into messenger RNA. Then After that, it is the same as the mRNA vaccine that I mentioned before. The mRNA get into the cytoplasm of the cell. The ribosome in the cell translates the mRNA and produces the spike protein. And the spike protein gets out of the cell, and our immune system in the body responds to the fake attack mounted by the spike protein. So the new machinery that I introduced in this slide is the RNA polymerase. Now, the RNA polymerase is another amazing machine. It's like a machine tool that makes copies, that actually copies a DNA into an RNA. Now, by tweaking the DNA, which we can do these days, we can then produce any protein that we want. Again, the combination of the software aspects of this product, which is in the form of the genetic code that we can edit more easily now than before, and the physical objects, which are the various molecules that we have been dealing with. A combination of these things actually are enabling us to produce novel vaccines to fight these diseases. Now, let me now talk about what these products, the novel products that I talked about so far, how they fit in within the traditional ways in which we engineers have been dealing with product development and manufacturing. So in this slide, I show you the classification that was proposed about 25 years ago by Ulrich and Eppinger in their famous book, Product Design and Development, which is in the 7th edition now. So this is a very popular book that is used in undergraduate and postgraduate classes around the world, both in the engineering schools as well as in the management schools. So what they have done is to look at the product development process, surveying many industries around the world, and they had come up with 8 product classifications based upon the product development process. So you can see from the top to bottom, the 8 of them. I will address each one of them in some detail in this talk, in the rest of the talk. But for the moment, I have circled the platform products, because this is the classification that addresses the products coming out of a platform. So what they say is that the product development team assumes that the new product will be built around an established technological subsystem. That is a technology platform. So the example that they quote is consumer electronics, computers, printers, and so on. But in this particular case, these are the novel vaccines as well as even traditional vaccines. So the key, as I mentioned before, is you need a biotechnology platform. Biotechnology in the form of the lipid nanoparticles, or our ability to edit DNA and RNA, and also our ability to manipulate the viral vectors. So all these things are biotechnology that have been developed to a level of maturity. And the interesting thing is that these biotechnologies have been under development for a while. So the underlying platforms for the vaccines did not occur just in the last 2 years. The science and the basic technologies have been under development for a while to fight lots of other diseases such as cancer and HIV and so on. And finally, when these technologies have been in the works for a while, and the pandemic started 2 years ago, nearly 2 years ago, we realized that it is possible to apply these underlying technologies coming from the technology platforms into the products. Okay, so now let me say a few things about it. I mentioned at the beginning that the pandemic is also teaching us biology. In fact, without the modern understanding of biology, the current biotechnology will not be possible. And without the current biotechnology, the new vaccines, the novel vaccines would not have been possible. But we have to recognize that biology is complex. But the recent advances has given biology a modern look, and it has made it more interesting. So there are two aspects of the modern biology that I would like to emphasize. The first is that the molecular and structural biology are providing us a mechanistic understanding of biology. So since I come from a mechanical engineering background, and some of the audience in this lecture are also coming from mechanical or electrical engineering, I want to tell you that the modern biology at the molecular level looks more like mechanical and electrical engineering. So that's very encouraging. And not only that, the bioprocesses that are taking place at the molecular level look like the factory processes, that is the manufacturing processes for cutting and joining material that we have been using so far. Now the body is using the cutting and joining of molecules to produce new molecules. So this is a fascinating subject, and I want to communicate to you that this is very exciting. And these developments have been around only for the last 20 years or so, because biotechnology has given us the tools to translate the science into useful products. So these are very exciting times. The other thing that I would also like to point out is that the gene sequencing and gene editing are providing us an informational understanding of biology. So part of the modern biology looks like software. So we can actually read, copy, and edit the genetic information. And this is very exciting. Now, the cost of sequencing genes have come down dramatically over the last 20 years. And that's very fortunate, because just when we needed it to fight the current pandemic, we have the tools to do the genetic sequencing. We are very fortunate indeed. If we had the same epidemic, the pandemic that we currently have, about 10 years ago, I'm doubtful whether we would have been able to sequence it as quickly as we have been able to do now. So we are fortunate from that perspective. And the point is that the mechanistic understanding and the informational understanding of biology have made the modern biology very exciting and interesting. So this has also opened up a new bioeconomy. In fact, the market size of the biopharmaceuticals is now bigger than the market size of commercial aerospace. So this is a great commercial opportunity. And I would say that we may well be living in the century of biology. We are in the first 2 decades of this century, but I anticipate that the modern biology will have considerable influence, and I will say a few things about it in the last slides or so, on how I foresee the impact of the modern biology and biotechnology on the rest of the century as we do our engineering. Now, let me now outline the manufacturing aspects of these vaccines in 3 slides. Let me pick the messenger RNA as an example. So the first thing that we do is we want to take the messenger RNA first in the form of a DNA. So these are the deoxyribonucleic acids in the form of plasmids. So these are circular double-stranded DNA molecules that correspond to the spike protein that I have been talking about so far in the virus. So remember, the spike protein is the antigen, and that's the enemy that we want to attack. What we do is that we take the genetic code that corresponds to that particular spike protein in the form of a DNA. The first step so involves the molecular cloning of the DNA plasmids. These are the double-stranded circular strands. And then we infuse them into the E. coli bacteria. So on the left-hand side, you see the E. coli bacteria pictures. These are only about 1 to 2 micrometer long. So these are very small. What happens with the E. coli is that they duplicate. They subdivide and then they duplicate themselves. They split into 2 once in every 20 minutes or so. So after 4 days of growth, we have billions of copies of this E. coli. And then we break up the E. coli and take the DNA plasmids out of them. So starting from theoretically 1 DNA plasmid, within a few days, we can produce billions of copies of these plasmids. very accurately. In fact, the E. coli is very good in duplicating without making much error at all. In fact, it is very difficult as in our human efforts to produce identical copies of any object with this level of fidelity. So E. coli is an amazing factory. So it goes back to the previous comment that I made, that the molecular level understanding of biology amazes us because the nature works like a factory, very much similar to a mechanical and electrical engineering factories. So it's very fascinating subject that we are now addressing in creating the vaccines and so on. So in the first step, we make multiple copies, billions of copies of the DNA. So this is what the mRNA vaccine producers such as Pfizer and Moderna, they do the very first step of making multiple copies, billions of copies of DNA. And in the next step, we take the DNA and use it as a template to build the messenger RNA the strands, which takes about 4 days. And this particular the transcription of the DNA into RNA is done by the so-called RNA polymerase that you see on the left-hand side. It's again an amazing machine, a machine tool that's only about 5 nanometers across. So this is the electron microscopy image of that. The RNA polymerase is the enzyme that transcribes the DNA into RNA. And as I say, this is an amazing machine tool, very similar to the sophisticated machine tools that we have in our factories, except that, as I say, these things are a billion times smaller. Then the last step is to take the messenger RNAs and then enclose them, envelope them in lipid nanoparticles. So in the third step, the mRNA strands are put in an envelope of lipid nanoparticles. Then after these nanoparticles have been formed, we put them in vials and then we ship them so that they can be injected into the patients. The lipid nanoparticles that I show on the left-hand side that you see surrounding the spike mRNAs, mRNAs, and so on, they are amazing molecules because they self-assemble in liquid such as water. So here again, we don't have to mechanically assemble it ourselves as we do with automobiles and airplanes and so on. We don't have to do that. The nature has the ability to self-assemble itself. So this is an amazing thermodynamic process, and we are exploiting it to a great extent in our messenger RNAs, vaccines based upon the messenger RNA platforms. Okay, so I have given you a quick tour of the manufacturing process that is involved in one particular vaccine platform. This is the mRNA platform. Now let me quickly go through the rest of the characteristics of the classifications proposed by Ulrich and Eppinger. Now, we already saw that the platform products is one of the categories in the Ulrich and Eppinger classification of products. But the other one that I have circled in red here is there are technology push products where the team begins with a new technology and finds an appropriate market. Now, this has happened in the case of the novel vaccines because the biotechnology industry already had the technologies for editing, gene sequencing, and so on. They also had the technology for viral vector and the lipid nanoparticles to envelope the message. So they were able to quickly put these things together, integrate them together. So the novel vaccines are also technology push products. Now, then if you look at the other item that I have circled in red here, the process intensive products. The characteristics of the product are highly constrained by production processes. So the production processes that I took you through in the few slides before have there are three major production processes that are involved in the messenger RNA, where making multiple copies of the DNA using the E. coli and then using the RNA polymerase to transcribe the DNA into RNA, and then the lipid nanoparticle processes that will then encapsulate the messenger RNA into this tiny little bubbles. These are all highly developed processes, and the quality control of these things are very important. So the vaccines are also process intensive products. The products are also customizable products. New products are slight variations of existing configuration. I want to talk a little bit about this particular aspects because we have been witnessing various variants of the SARS-CoV-2 virus. You know that there have been alpha, beta, gamma, delta variants. Till recently, the Delta variant had been the dominant one. Now there is an Omicron variant, and we are all very concerned about it. And every day we are receiving news about how efficiently it is transmitting itself, or how virulent this particular variant is. The hope is that since this particular variant is only a slight variation of the original virus, we will be able to develop vaccines, new vaccines actually, if we need to combat the variants. So that's what companies are currently working on, and they seem to be confident about it. The reason why they can feel confident is that all we need to do is to sequence the new variant. And as I mentioned before, our ability to sequence the genetic code has improved tremendously in recent times. So this is giving us the confidence that we can customize the product to the variations very quickly. Now, it also turns out that all the medical products are high-risk products because we have to go through extensive testing. And there are strict regulations, the country regulations as well as international regulations that we have to obey before a drug or a vaccine is approved. And most of the drugs under development fail. For example, we saw that there are about 136 vaccines that are under testing now. Many of them will fail. So these are high-risk products. So we need to have the ability to deal with the risk associated with the products. And to some extent, government support will help. And that's what happened in the current pandemic in coming up with new vaccines very quickly. The last item that I want to talk about is the quick build products. Rapid modeling and prototyping enable many design build test cycles. So this goes back to the point that I mentioned that when we have a new variant in the virus, we can actually do the sequencing of it very quickly. And all that we need to do is to make some initial changes as though making just a change in the software. And then we can push through the entire rest of the processes the same and come up with a new product very quickly. So many of the companies that are doing the novel vaccines are telling us that within 100 days, they'll be ready with the new vaccine if we need to have new vaccines, that is modification of the existing vaccines for the variants that we are observing. So what I would like to do is to say that the novel vaccines seem to satisfy all the criteria that have been identified by Ulrich and Eppinger in the classification of products based upon the product development processes and the manufacturing that these products will be subjected to produce this product, the manufacturing processes that we will use to produce these products. Now, let me conclude with a couple of quick slides. So there are several engineering challenges because the process and quality control is very important. There are government regulations for bioproducts and bioprocesses. and measurement of critical quality attributes are very important. The logistics and delivery is still a challenge because the vaccines have to be stored at low temperature and they have to be transported under low temperature till it reaches the patient and we are injecting them with that vaccine. The supply chain has to be educated and trained, particularly the small and medium-sized manufacturers have to be trained, and we should be able to ramp up and ramp down the production. As you have more demand, we have to ramp it up, and as the pandemic or epidemic subsides, then you should be able to ramp it down. So these are all very interesting engineering challenges. Now, I also want to say that currently our focus is on vaccines because that's what is causing a lot of problem around the world. But the biotechnology platforms that I talked about are applicable to agricultural products. For example, we can apply these technologies and the platforms to reduce the use of pesticides and fertilizers. There is a lot of research development and practical testing that's going on in this area. There are also other biomedical products beyond vaccines. In fact, most of the blockbuster drugs are now biopharmaceutical products, such as the monoclonal antibodies. The biotechnology platforms such as mRNA have opened up new avenues for treatment of other diseases like even cancer and AIDS, which has defied vaccines for a long period of time. There is also exciting bioindustrial products because the bioindustrial products are the biofuels and biomaterials to replace the plastics. The biofuels are the ones that will replace the fossil fuel-based fuels. And in many cases, bioprocesses are more sustainable because they use biological processes which are very benign. So with this, I see that my time is almost up. So let me thank you for your kind attention. And then I'll be ready to take any questions that you might have. And now it's probably time for me to stop sharing if that is possible. If someone can stop me from sharing my slides, then I can join the rest of you with stop sharing. Let me stop sharing. And now I'm able to join the rest of you. So I will turn it over to our host, and then we can take some questions if we have some time.
Thank you, sir.
Sir, Chairman, sir.
Yes, sir.
Yes, sir.
Thank you. I just listen the lecture. It is very interesting lecture, Dr. Srinivasan. Actually, just from your lecture, it comes to us that biology will be the future of our industry, right? Today or tomorrow. So I hope that you have mentioned that molecular and structural biology, mechanistic understanding of the biology is very important for mechanical engineers also. So we should change our curricula actually in the undergraduate as well as postgraduate. We should include biology or mechanistic understanding of the biology.
I agree.
Right, to counter these things. Now, you have compared machine tools with these small machine tools. Now, these are all small machine tools and creating lot of mass productions, that vaccine and all these things. And which will be the important thing to help the human beings, in the mankind. This is the need of the hours, and which as a mechanical engineers you are doing in your country, in USA. But in India also we should do it, and we should encourage our students to study biology, molecular biology and all these things. Very interesting lecture and very relevant and pertinent, this lecture for these situations, pandemic situations. Very important, very good lecture. So I have listened, many new things I have come to know from your lecture about vaccines, how to manufacture all these things. Now, I hope that this lecture is open to the audience. If anybody having any clarifications or any queries from Dr. Srinivasan, he is here online, so he can answer your queries. Okay. Just if anything, any queries is there, Dr. Tal?
Yes, sir. Yes.
Anyone?
You can raise your question.
Right.
Yes, sir. I hope I'm audible, sir.
You are.
Yes.
Thanks. So I heard about the processes of the cloning and the molecules. It was really wonderful to hear. Now I have a curiosity that whether these technology and these processors have been can be used to harness energy in the energy sector. I have a curiosity on that just from hearing from this technology.
Yeah. Okay. So there is a lot of talk these days about circular economy related to energy. You may have heard about that. What it is that instead of using fossil fuels, can we use fuels that are manufactured from biological products that are there in nature? So there is a lot of work that is currently going on in taking biomass and using the biological processes to convert them into biofuels. Now, these biofuels can be used very directly into jet engines and so on. And in fact, Boeing has announced that by the end of this decade, that is by 2030, all the Boeing planes will be flying using biofuels, not the fuels that are taken from the ground, but taking the biomass and converting them into hydrocarbons. Now, the idea is that the biofuels, whatever CO2 that they emit, can be absorbed by the plants, and then we can establish a circular economy around that. So that's one prime example where people are currently working on using the biological processes to generate fuels. Now, your question also triggered me into the thought, in recent times, we heard about how the Delhi area has been affected by the burning of the stubble around by the villagers around Delhi, causing smog. And there was an emergency declared in Delhi a month or two ago, shutting down all the schools because the air is so polluted. If only we can take those stocks, the biomass, and use bioprocesses to convert them into biofuels that the farmers can use in their tractors, it's a win-win situation for all of us, isn't it? So there are lots of work that's currently going on topics such as this. I hope I have answered at least part of your question.
Yes, sir, I got it.
Thank you, sir. So I will read out the questions in the chat box, sir.
Okay.
Mr. Mohan A is asking, dear sir, how do you approach designing the mRNA instructions for cells to build unique spike protein into a mRNA vaccine for mutated variant like Omicron?
Good. So we are currently doing that. And what it is that you first need to sequence the genome within that mutated virus. And we can do that. That is, we take the virus from a patient who has been infected with the new, like Omicron variant. And that's how actually they discovered this is a new variant, not the Delta variant, but a new variant. Once you have the sequence, which is in the form of, ACGU for the RNA, then we can actually make a DNA corresponds to this particular variant. And then the rest of the processes are identical to what I have described in 3 slides that I showed how to make the mRNA vaccine. All that you need to do is to take the plasmid, the circular DNA that corresponds to the sequence, inject it into E. coli, multiply that into many, many copies and so on, and follow through the rest of the process. That's what many of the mRNA companies are currently working on, like Moderna and Pfizer. And they are ready, if we really need the new vaccine, within 3 months, 100 days or so, they say that they can come up with the new vaccine. I hope I have answered that question.
Yes, sir. So the next question is from Jonathan. So he is asking that as we know that all these mentioned are process intensive products, what is the common challenge we face in the mass manufacturing of these products?
So in one of the last slides that I mentioned that process and quality control is an important engineering challenge. So many of these pharmaceutical companies, including, in fact, I have to mention that India has been a very big manufacturer of vaccines. In fact, the Serum Institute of India is manufacturing the viral vector vaccine under license from AstraZeneca. So if you talk to the companies, including the ones that are currently manufacturing them in India, they will tell you that the various steps that I have mentioned to you, that is the bioreactor in which the E. coli is cultured, that is grown. So very strict quality control is necessary in these manufacturing processes. The quality control and the process control, keeping the process parameters under very strict control, contamination control, the water that we use, and you making sure that the water is pure water and it is in an uncontaminated environment. So these are all very interesting and important challenges. And the biotechnology area refers to them as GMO, good manufacturing operations, or GMPs, good manufacturing practices. So if you look at what these good manufacturing practices are, these are very, very similar to good process controls and good quality controls that we practice in some of the engineering industries. So that's my quick answer, but the details is in the actual issues. What are the various molecules that are involved in this manufacturing processes? And drug and food manufacturing is highly regulated, both in India as well as in other places. So we have to observe all the standards and the regulations in manufacturing these things. I hope I have answered your question.
Yes. So the next question is from Ram Abhishek. What are all the manufacturing advancements we have to make to produce vaccines in even more quicker lead time?
We can make them quickly because, as I said, the sequencing has been one of the major advances. How quickly we can sequence the new variants, or in any pathogen, how quickly can we sequence the informational aspect of that genetic code. And we can do that very quickly. Within a week, we can do that. Then after that, the rest of the processes are governed by, as I mentioned to you. Now we can shorten the 3-month or 100-day that people talk about to maybe half the time, because people are looking into integrating the various steps. People are also looking into the current batch processes, because this is the manufacturing process that is currently used. So these are the big vats or big drums in which the molecules are grown, and then we transfer that from one batch to the other. If we can use continuous manufacturing, then we might be able to shorten the time between the various stages in the manufacturing processes. So people are looking into the continuous manufacturing to replace the current fed batch manufacturing processes. So that can help. But we also have to remember that we have to test these products. We have to test these products in the lab on animals first, and then we have to recruit people so that we can do the testing on human subjects. So the testing portion of that will take some time, because there are some very strict regulations on how you do the testing. But from the manufacturing perspective, we can do that very quickly now, and we may be able to do it even more quickly using continuous manufacturing processes as opposed to the current batch manufacturing.
Okay, sir. So Mohan A is having another one question. Sir, I have read that beyond vaccines, mRNA also to trigger the immune system to target specific cancer cells. Is that true? Could you explain about it?
this is a very interesting and important question, because many of the biotechnology platforms that I talked about, particularly for mRNA as well as viral vector, they were initially developed for cancers and other pandemics such as HIV/AIDS. Now, so far, we have not succeeded very much, but the scientists are hoping that the lessons that we have learned from the current pandemic, particularly how successful mRNA has been, is giving us a new life into the attack of the other diseases like cancer and a whole bunch of other things. In fact, people are receiving yearly flu vaccines for the common flu, influenza. We might be able to have mRNA vaccines for them very quickly. And that would be very beneficial. And there is also a talk about a universal vaccine, that is one vaccine that can protect us against many viruses, but still within the realm of viruses as opposed to cancers. But people are now enthused about our ability to trigger immune response of our body, very targeted immune response of our body using the mRNA technology, so that the cancer cells can be attacked and destroyed. So that's an area that people are currently very actively working on. And let's hope that they will succeed.
Thank you, sir. I myself has a question, sir.
Sure.
What will be the future after COVID-19 recovery? Will there be many more viral infections with short span of time, like every 10 years or so? Is there any prediction about that, sir?
Actually, there is a course at MIT. So it's available in YouTube. It just concluded on 8th, that is day before yesterday. This course is about what have we currently learned and how can we be prepared for a potential next pandemic. So the name of the course is Biology 7.00. So if you search in YouTube, you will be able to find it, MIT Biology 7.00. The title of the course is COVID-19, SARS-CoV-2 and the pandemic. And experts from all over the world are giving lectures on what they have learned, what we have learned, and what we can do in the future. And one of the questions that they address is, what are the chances for a major pandemic like this from striking us? And some of them are worried that we may have lucked out actually currently in the current pandemic, because, to put it very bluntly, the death rate in the current pandemic, the COVID-19, is for 100 people who are actually infected with it, only 2% of them die if you don't have vaccinations and so on. And that's bad. It's very sad, but it is low compared to 30% of the infected people dying. So people are worried about whether we will have new viruses that will have high transmissibility, such as the Delta variant and now what looks like the Omicron variant, but that will have very high mortality rate. That's what they are very much worried about. In fact, some of the scientists have said that that's their nightmare. Now, we don't know whether this will happen, but the best thing we can do is to be prepared, that if such things were to occur, then we should be prepared with our manufacturing capabilities, with our quickly designing the product capabilities, distribution capabilities, because these are the things that we can do as scientists and engineers. But then there is also the political aspect of it, social and political aspects of it, that others have to take care of. But the best that we can do is to educate the public at large and be prepared for a potential calamity such as the one that we just talked about.
Thank you,
Sir, I'm Ramesh Babu. Can I ask one last question, sir?
Sure.
General question. So is it like a mistake by man, the coronavirus, because we certain things we are not supposed to do, we are doing against the nature. That's the reason we are affecting this. Like eating certain things which is not supposed to eat, bats. That's what I heard. I'm not sure whether correct or not. So in return, nature will attack us.
Okay. Well, you see, one of the lectures in the MIT course that I just mentioned to you, he talked about the history of vaccines. And what he pointed out is that viruses have been in the world long before human beings showed up on Earth. Viruses are some of the longest living species on Earth. And they have been attacking, the viruses have been attacking bacteria when the world was ruled by bacteria. And then they keep attacking all living organisms. Even before we human beings started, as you say, adopting bad practices in recent times, even before that, the viruses have been attacking us. In fact, smallpox, as you know, was one of the most destructive virus, and many people died of smallpox, but we have been able to come up with a vaccine. Polio is another major disease, and we have been able to come up with a vaccine to combat that. So I would say that some of our practices may contribute to the problem of the virus attacking us. But the viruses did not come just because we human beings started behaving badly. The viruses have been around even before the evolution of human beings. They have been there for more than 2 billion years. So what can I say? The scientific point of view is that the viruses are there. They co-evolve along with human beings. So people compare it like a horse race. The virus is always trying to evolve, and we human beings are also trying to evolve, and it is a race between the two of us. Who is going to be ahead of whom? The virus was ahead of us a couple of years ago when the pandemic started, but hopefully we have caught up and we are ahead of the virus. But it is a constant struggle, and we have to keep improving our science and technology to watch out for all the other things that nature can throw at us. So that is the level of scientific understanding that we currently have. Other than that, I won't be able to offer any expert opinion on the moral issues of how we are behaving badly in the world. We can suggest some better hygienic behavior, but other than that, I can't say much more than that.
Thank you, sir.
Thank you, sir, for your crisp and clear answers. Now we are handing over the session to our chair.
I thank you, Dr. Vijay Srinivasan, for delivering this type of very, very pertinent and relevant lecture to this pandemic situation. Lot of challenges we have to face in the coming days, and we have faced also a lot of challenges, and we have solved a lot of challenges. As in India, the population size is very, very large, more than 130 crores of men, and most of the men are in rural conditions, like poor, not very economically sound. So in the context of India, how this biotechnological platform is developing, how we can encounter this type of situations in coming future, considering these poor masses? Right? Just what is your answer just in this context?
I think India has a very important role to play. As I may have mentioned very briefly, India has been a leading manufacturer of vaccines in the world. India has supplied vaccines for lots of other diseases, not only for people in India, but also for the rest of the world. I have been very proud of the fact that companies like the Serum Institute of India, and now more recently, the Bharat Biotech and so on, these are all fantastic companies, manufacturing companies in India that have been manufacturing. Now, admittedly, in the past, that is before 2 years, all the vaccines that have been manufactured were based upon the traditional vaccine platforms, such as the inactivated virus and so on. But the whole new area of novel platforms using messenger RNA and viral vector, protein subunit, and so on are opening up great opportunities in India, not only to supply medicine for citizens of India, but also to supply to the rest of the world. You know, many of the underdeveloped world depends on India to provide vaccines. And India has the ability to do that, not only to satisfy the needs of India, but also to supply the needs of the rest of the world. So my hope is that we have started in India, but as I mentioned, the Serum Institute of India has been manufacturing the AstraZeneca BioNTech vaccine under license from AstraZeneca. But hopefully, we will grow our own native ability to design and manufacture these types of vaccines and other bio components by educating our workforce, by improving the knowledge base of our industries, and we can actually ramp up our manufacturing capabilities. Interestingly, you don't need too much energy to manufacture these bio products because these are benign products that can be manufactured under near body temperature, that is 37 degrees Celsius, near atmospheric pressure, and near neutral pH value of about 7. So these are all benign processes. So we don't need to set up high energy intensive manufacturing operations. What we need are very good underlying science and technology, a very good understanding of the molecular biology. And as I mentioned before, and as Professor Bhattacharya, you also observed that these are all very much like machine tools in factories, operating like assembly lines. And a good understanding of this particular aspect, the mechanistic aspect of what's going on, and also the informational aspect of it, so that in India, we have very, very good IT related talent. So combining this mechanistic understanding with the informational basis for this is eminently possible in a place like India. So I'm looking forward to a great future for this particular type of industry in India, and the market is booming for this. So that's my fond hope.
Thank you. Thank you, Dr. Vijay Srinivasan. So we listen a lot of things, we learn a lot of things from you, and you have encouraged us to work a lot in this area of biotechnical platform. Right. So I, on behalf of the organizing committee of Aimtdr, I thank you. Thanks a lot to you. Right. So with this, I pass this to Dr. Tal for concluding the session.
Thank you, sir. Once again, we thank our keynote speaker, Dr. Vijay Srinivasan, and our session chair, Professor Vijay Bhattacharya, for spending their valuable time and giving such an insights about COVID-19. Thank you very much, sir. Thank you.
Thank you very much.
Thanks,
Thank you
thanks.
and
Thanks.
goodbye.
Bye.
Thank you, sir. Take care.
Bye.
Bye. Okay.
The session is officially closed and the next session starts tomorrow as per the plan. Thank you all participants. Thank you.